This is the final exam practice B for Math 1100. So with the limits, oftentimes you can evaluate a limit using direct substitution. Direct substitution means you just plug this value into the equation for x. Problem is 2 subtract 2 is 0. So direct substitution at this point fails, but we may be able to factor the numerator. We got to carry this negative sign with it. So then the x minus 2 can factor out. So it's the limit as x approaches 2 of the opposite of x plus 1. So now we can use direct substitution. Plug in 2, 2 plus 1 is 3, 3 times negative 1 is negative 3. Now for question 2, A and B, there's two ways you could do this. Numerically, meaning plugging in values. So as x approaches negative infinity, you could plug in values for x that are becoming more and more negative. Negative 10, negative 100, negative 1,000, negative 10,000. The table would look like this. So I got x equals negative 10, x equals negative 1,000, x equals negative 10,000. And what's happening is the values are getting smaller and smaller and smaller. So if this continued to negative 100,000, negative 10 billion, these would continue to get smaller and smaller, essentially heading towards 0. So from that conclusion, numerically speaking, we could say that the limit as x approaches negative infinity of our function is equal to 0. Now we can also do a numerical analysis similar to that for part B. As x is approaching 2 from the right, that means we're getting closer and closer to 2 from the right side of 2. So starting at like 3, and then we could go 2.5, 2.4, 2.3, 2.2, and so on. So that the table would look like this. So you can see I'm plugging in numbers on the right side of positive 2, getting closer and closer to 2 from the right side. And you can see these values here are going more and more negative. So if the pattern continued, this would eventually reach negative infinity. So from that, you can conclude that the limit as x approaches 2 from the positive of our function is negative infinity. Now this would be the way to do it if you want to do a numerical analysis of this problem by plugging in values according to what's happening here. The other way to consider this is looking at the graph. Now this, if you're comfortable graphing rational expressions like this, then graphing it wouldn't be a bad idea. So the graph would look something like this. So x squared minus 4 factors into x minus 2x plus 2. Those would be your two vertical asymptotes. Negative 2 and positive 2. And then the horizontal asymptote, you have to do a comparison of the degree of the numerator to the denominator. This is degree 1, this is degree 2. So if the numerator has a smaller degree, remember that puts your horizontal asymptote at 0. So we have a horizontal asymptote at 0. Then you find the y-intercept by letting x equal 0. So this would be 0 over 0 minus 4. 0 divided by anything is 0, so your y-intercept is 0, which also acts as your x-intercept. And the rest of this is just plotting a few points to graph. So if you chose a few points like x equals 3, x equals negative 3, and then a few points here, this is what your graph would look like. So you can see for part A, as x approaches negative infinity, this is negative infinity. As x approaches negative infinity, we're getting closer and closer to 0. And then as x approaches 2 from the positive side, here's 2 from the positive side. So as we're approaching 2 from the positive side, we're approaching negative infinity. So you can also use the graph to answer both of those questions. Okay, question 3. For part A, we need to find the intervals increase and decrease. So that's going to come from the first derivative and then we set it equal to 0. I'm going to factor out a 3x. So we have x equals 0 and x equals 2. So once you have your critical numbers, remember you have to place them on a number line. And test values. So if we tested -1 here and +1 and +3, those test values go into the derivative to see if it comes out to be positive or negative. So if I plug in -1, we get -3 times -3, which is positive. If I test +1, I get 3 times -1, that's -3, so that's negative. And if we test +3, we get 9 times 1, that's positive. So positive indicates an increasing part of the graph, negative indicates a decreasing part of the graph, and positive over here indicates increasing. So it's increasing from negative infinity to 0 and from 2 to infinity. So those are the two increasing intervals. I'm actually going to write those. So negative infinity to 0 and from 2 to infinity, and then its decrease between 0 and 2. And then for part B, find all the points of relative minimum and maximum. That's from this information here. If the graph is increasing and then decreasing, that means we've got a relative maximum here when x equals 0. And then if it's decreasing to increasing, we've got a relative minimum here when x equals 2. So we have a relative max when x equals 0. We got to find the y part to that. And then we have a relative min when x equals 2. Now if we go back to the original function, because now we're talking about actual points on the graph. Minimum and maximum values are points on the graph, so that's got to come from the original function. Now the original function I've given two forms, okay, the general form and the factored form. You could plug 0 into either one. If we plug 0 into the general form here, we get 0 plus 4, which is 4. If we plug in 2, that's 8. 2 squared is 4. 4 times 3 is 12. 8 minus 12 is -4. -4 plus 4 is 0. So 0, 4, 2, 0. Okay, now for part C, find all the intervals of concavity. So for part C, concavity is going to come from the second derivative. So we're going to take the derivative of the first derivative. That's going to be 6x minus 6. Set that equal to 0. So that's, right now, a critical value. We need to test concavity by choosing test points. So if we choose a test point of 0 and a test point of 2, we plug those into the second derivative. So if we plug 0 in, we get 0 minus 6. That's negative. That means it's a concave down interval. If I plug in 2, that's 12 minus 6, which is positive. So it's a concave up interval. So it's concave up from 1 to infinity and concave down from negative infinity to 1. And then for part D, the inflection point only happens if it switches from concavity. So this is concave down to concave up. So that is an inflection point. So the inflection point would be 1 And again, since this is an actual point on the graph, we'd have to come back to the original function. If you plug in a 1, let's do the factored form here. 1 plus 1 is 2. 1 subtract 2 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. So we have an inflection point at 1 comma 2. Now part E is graphing the function. We need to have some more information here. So the factored form is going to give us the zeros. We have a 0 here at x equals negative 1, and it's going to cross through because the multiplicity there is odd. Remember, a multiplicity is how often that factor repeats. It repeats once. This is repeating twice, so it's going to bounce at x equals 2. So it crosses through here, bounces here, and this is a third degree polynomial. So the end behavior is left side's going down, right side's going up. That's a typical end behavior of a third degree polynomial. Unless there was a negative in front, which means the left side's going up and the right side's going down. So we know that the left side's going down, right side's going up. This is the highest point in that area. That's the relative max. This is the relative min. It crosses through right here, bounces at x equals 2, like that. Okay, two things we have going on here. This is a product because it's this multiplied by this, so we have to have product rule, and then this is going to require chain rule when we do the product rule. So, for example, if we want to call that part F and this part G, the product rule is F prime G plus G prime F. So F prime here is going to require chain rule. So F prime, drop that exponent of 3 in front, decrease it, and then multiply it by the derivative of the inside part. The inside part here is going to be 12x squared. So that's F prime times G plus G prime is just going to be 8x cubed times F. All right, next we look through and see if there are any common factors to factor out. Like this 4x cubed plus 3 can factor out. It looks like we have an x squared here that can factor out. And 3 times 12 is 36, and here we have 8. So the common factor there would be 4. So if we factor out a 4x squared and a 4x cubed plus 3 squared, then what do we have left over? Out of the 12x squared, the x squared came out, so 12, that leaves a 3. 3 times 3 would be a 9. And then the 4x cubed squared came out, but we have a 2x to the 4th plus 1. And then from this side, an x squared came out and a 4, so that leaves a 2x. And then one of these 4x cubed plus 3s. And then if we combine like terms in this parenthesis, we're going to have an 8x cubed and an 18, sorry, this is 8x to the 4th, and this is 18x to the 4th. So it's a 26x to the 4th. And then we're going to have a 6x. And then here we're going to have a 9. And then we have these terms in front that we factored out. All right, with question 5, what you're going to want to do is use rules of logarithms before you find a derivative. So if we rewrite the numerator as x to the 2/3. Then we can use the quotient rule of logarithms and separate that into two logarithms using subtraction. And then we can bring this exponent down in front of the natural log. And once you've simplified the logarithms as far as you can go, now use derivatives. So the derivative now, y prime, the derivative of natural log of x is 1 over x. And then the derivative here is 1 over this expression multiplied by the derivative of that. Okay, for question 6, we are going to use the quotient rule for derivatives. So it's the bottom function multiplied by the derivative of the top function. So this whole thing here is the derivative of e to the 4x to the 4th. Because remember, the derivative of an exponential is the exponential multiplied by the derivative of the exponent. And then we subtract the upper function multiplied by the derivative of the bottom function, divided by the bottom function squared. Okay, and then what's left is just to see if there's any common factors in the numerator to factor out. We have e 4x to the 4th as a common factor, and then we have 16x cubed here, and we have 3x squared. So the only common factor there is x squared. So common factor would be x squared e to the 4x to the 4th, leaving from this part of it, we're going to have a 16 and an x, and then this, so that'd be 16x times x to the 3rd plus 5. From this side, the e to the 4x to the 4th came out. The x squared came out, so that just leaves a 3. And then we can just simplify inside here. We're going to have 16x to the 4th, and then 16 times 5 is 80, so that's 80x. All right. For question 7, if we differentiate this expression with respect to x, we're going to have to use implicit differentiation when we differentiate y with respect to x. So the derivative of 5y is 5 times dy dx. The derivative of 5x cubed is 15x squared And the derivative of 5y squared is 10y dy dx. Now we get dy dx by itself, so I'm going to move this term to this side by subtracting it. Then factor out the dy dx from that side. Then divide by the 5 minus 10y to get dy dx by itself. And you notice that all of these coefficients are divisible by 5. So we can simplify it by dividing each of those by 5. Okay, question 8. The partial derivative with respect to x we're going to differentiate this first term with respect to x as if y was a constant. So 3 and y are just coefficients, so we're really just differentiating x squared, which becomes 2x. The 2 multiplies the 3, so we have 3 times 2, which is 6. The derivative of 2y squared is 0. The derivative of 6x squared is 12x, and then the derivative of 8 is 0. The first partial derivative with respect to y, now we differentiate this term with respect to y as if 3x squared were a coefficient. So 3x squared times y, if we differentiate with respect to y, we're just left with the coefficient 3x squared. For this term, the derivative is 4y. For this term is 0, and this term is 0. Okay, now we get into integration. So we have a function in the form of a fraction, a rational function. So we could try to use the natural log rule. So the integral of du over u is natural log of u. We could try that. So if we wanted to let u equal x squared plus x, then du is 2x plus 1. So the problem is we cannot make 5x minus 2 equal to 2x minus 1 so that we can get du over u. So natural log rule isn't going to work. We don't really have a function inside of a function, or we can't necessarily move this term up to the numerator to try to get u to some power multiplied by du, like the general power rule. So the option we have left is integration using partial fractions. So if we consider the denominator in factored form, then it has two partial fractions. And then if we multiply the whole thing by the lowest common denominator, we would end up with 5x minus 2 equals a times x minus 1 plus b times x plus 2. Now, if we let x equal 1, that's going to cancel. If we plug in 1 right here, 1 subtract 1 is 0, 0 times a is 0, leaving us only b to solve. So if we plug in 1, we're going to get 5 minus 2, that's 3. Here we're going to get 0. Here we're going to get 1 plus 2, that's 3. 3 times b is 3b, so b is equal to 1. If we let x equal negative 2, then here we have 5 times negative 2, that's negative 10. Subtract 2, negative 12. Here negative 2 subtract 1 is negative 3, so that's negative 3a. So a equals 4. So the partial fraction is 4 over x plus 2 and 1 over x minus 1. So the integral, the original problem becomes the integral of 4 over x plus 2 dx plus the integral of 1 over x minus 1 dx. And that's going to become 4 times the natural log of the absolute value of x plus 2 times the natural log of the absolute value of x minus 1 plus c. For number 10, what I'd recommend is moving the term in the denominator up to the numerator and changing the exponent to negative 5. So this would be 5x to the 5th minus 2 to the negative 5th power multiplied by 50x to the 4th dx. And then we could use u substitution and the general power rule. So if u is equal to the inside function 5x to the 5th minus 2, then du is 25x to the 4th dx. So we have x to the 4th dx, the 50 should be a 25. So I'm going to go ahead and move the 50 out there, multiply by 25, and then divide by 25. So then it becomes 50 over 25, that's 2, times the integral of u to the negative 5th du. This is equal to 2 times u to the negative 4th divided by negative 4. So then we can change u back into its definition, 5x to the 5th minus 2, so it's like that. Okay, typically when natural log of x is involved in integration, we're going to have to use integration by parts. So that means we need to have u and dv. So it would not make sense to have dv equal to the natural log of x because there is no easy way to integrate natural log of x. So then that means u is going to equal natural log of x and du is 1 over x dx. So then dv becomes x squared and v is the antiderivative, which is x to the 3rd over 3. And the dx goes there. Okay. So then remember the integral of u dv, which is what we set up here. This is u. Actually, this is u right here, and that was dv. So the integral of u times dv is u times v minus the integral of v times du. That's integration by parts. So we have u times v minus the integral of v times du. So I'm going to go ahead and clean this up just a little bit. I'm going to take this 1/3, 1/3 right here, and move it in front of the integral sign. And then x to the third divided by x is just x squared. So then the only thing left to compute is the antiderivative, or the integral of x squared, which is x cubed over 3. This x to the third over 3 came from here, the antiderivative of x squared. And then just multiply these two together. Okay, we have a quadratic and another quadratic. So chances are they're going to be something like this, where we need to find the intersection point and then the area between them, which is most likely what's going on there. So first thing is find the intersection point. You find the intersection point of two graphs by setting the two equations equal to each other. So x squared is equal to the other one. Okay, and then getting one side equal to 0, I'm going to go ahead and move all these terms over to here. So add the 2x squared to get 3x squared. Add the negative 4x over to get, and then subtract the 4 from the negative 5 to get negative 9. Factor out a 3. And then factor into x plus 3, x minus 1. So we have from 1 to negative 3. So we need to figure out then which function is the upper function, which one is the lower function in this interval from negative 3 to 1. Now this interval includes 0. So 0 is a pretty easy number to test. So here, for x equals 0, we get y equals negative 5. For this one, for x equals 0, if I plug 0 in, we get y equals 4. So for this interval, negative 3 to 1, this one's the upper function. This one's the lower function, because when we plugged in the same value for x, 0 and 0, this one gave us a lower value, this one gave us a higher value. So we're ready to set up the integral from negative 3 to 1. We do the upper function minus the lower function combine those, and then find the antiderivative. So there's the antiderivative. Now we use the fundamental theorem of calculus, plugging in our bounds of integration. So we have negative 3, 1. We start with 1. So the value of the antiderivative when x equals 1, we're going to have 1 cubed times negative 1. So 1 cubed is 1 times negative is negative 1. And then we have 1 squared, which is 1. 1 times negative 3, so that's minus 3. And then 9 times 1 is positive. So that's the antiderivative of the upper bound. Then we subtract the value of the antiderivative of the lower bound. So negative 3 cubed is negative 27, multiplied by negative 1 is positive 27. And then negative 3 squared is 9. 9 times 3 is 27, that's minus 27. And then, excuse me, negative 3 times 9 is minus 27. So here we get 5. From that we get negative 27. 5 plus 27 equals 32. For number 13, we have an improper integral because one of the bounds of integration is infinite. So we need to turn this into a limit. So the limit as x approaches b of the integral from 0, replace that upper bound of infinity with now b. So we need to find the antiderivative. We can use the rule e to the u. So if we want to let u equal negative x squared, then du would be negative 2x dx. So we have the x and the dx. What we're missing is the negative 2. So if we multiply by negative 2, then we have to multiply by negative 1/2 out there. So then I'm going to drop the limit here for a second and just focus on the antiderivative. So we have negative 1/2 times the antiderivative from 0 to b of e to the u du. So this is negative 1/2 e to the u, which is negative 1/2 e to the negative x squared. We're going to evaluate that from 0 to b. So that's negative 1/2 e to the negative b squared. That's the antiderivative at the upper bound, minus negative 1/2 e to the 0 power e to the 0 power is 1. 1 times negative 1/2 is negative 1/2. Subtract a negative is plus. Okay. So this is plus 1/2. And then here I'm going to move e to the negative b to the opposite of b squared. I'm going to move that down to the denominator with the 2. So it's negative 1 over 2e to the b squared. Now I'm going to include the limit as b approaches infinity. So if we have a number approaching infinity, meaning b is getting larger and larger and larger, you square it so it gets even more large. E to that increasing power just means 2e to the b squared is a numerical value that's increasing very, very rapidly and very, very large. But negative 1 stays the same. So negative 1 over a big number that's getting bigger and bigger and bigger, the overall value of that fraction gets smaller and smaller and smaller towards 0. So we would say this value of the fraction approaches 0 as b approaches infinity, and then 0 plus 1/2. So it equals 1/2 right there. So since we were able to evaluate that limit, we would say converges to 1/2. Okay, question 14, we have a price function here. They're describing cost. So for each smartphone, we have $60 per smartphone. And then just for every day there's $6,000 of overhead. How many smartphones should the company manufacture and sell per day to maximize profit? So remember, profit is revenue minus cost. Cost, they want it per day. So we have a $6,000 fixed cost per day plus $60 per smartphone. And X is the number of smartphones. So $60 per smartphone is $60 times X plus the $6,000 fixed cost per day. So the cost is C equals $60 times the number of smartphones plus that $6,000 overhead. Revenue is equal to X times P, price, which is X times the price that was described, $130 minus 0.05 X. So now profit is equal to revenue minus cost, which is revenue minus cost So we have profit here. Once we combine those like terms of 130 and 60, we have negative 0.05 x squared. And then 130 minus 60 is 70. So there's profit. And the reason we wanted a profit statement is that's the question. How many smartphones should the company manufacture and sell per day to maximize profit? So we have a profit statement. Now remember, maximize just means find a minimum or a maximum value, really. This is a quadratic because it's negative 0.05 x squared and it's facing upside down. So the very top of that parabola, the vertex, is the maximum profit. So remember how we find minimum or maximum values is by finding a derivative. So the derivative of the profit, P prime, so we're going to have negative 0.1 x plus 70. Now we set that equal to 0. So we're going to subtract 70 and then divide 70 by 0.1. That's going to give us 700. So x equals 700. Now we need to prove that that's a maximum value. So if we have 700, we would need to plug in something on the left side of 700, like x equals 1. If we plug that into the first derivative, x equals 1, this is negative 0.1. Negative 0.1 plus 70 is a positive number, so we have positive here. If we plug in something on the other side of 700, like 900, 900 times negative 0.1 is negative 90 plus 70, that's a negative number. So what the plus number means is it's increasing and then it's decreasing after 700. So 700 is the maximum value. The question is, how many smartphones should the company manufacture and sell per day to maximize profit? X represents number of smartphones. And the question is how many smartphones. So what they're asking us to find is X. We've proven that X is a maximum value. So the answer is 700 smartphones. If they produce and sell 700 smartphones per day, they're going to maximize their profit. Okay, question 15. We have a circle that's growing in area because oil keeps spilling out of this tanker. How fast is the area of the spill increasing? So the question is, how fast is the area increasing? So in other words, what's the rate of change of area? How fast is the area of the spill increasing? That's rate of change. Rate of change is derivative. Now, how fast is a matter of area per minute. So what they're asking us to find is the rate of change of area, dE, or dA rather, the rate of change of area with respect to time, because it's going to be yards squared per minute. So find dA dt when, right here, the radius of the spill is increasing, so that's dr, the rate of change of radius is dr with respect to time per minute. So when dr dt equals 7 yards per minute. Now, the area of a square is pi times r squared. So then the derivative, dA, with respect to time, so we have the derivative of r, but with respect to t. So this is one of these situations, like a question earlier on this practice test, where we're differentiating one variable with respect to another. So that's implicit differentiation. So the derivative is going to be 2 times r times pi. So this is pi times 2r, but then we need to multiply by a dr dt. That's the implicit differentiation part here. The derivative of r with respect to time is dr dt. They're asking us to find dA dt. So we need something to plug in for dr dt, which is 7. And they're asking how fast is the area of the spill increasing when the radius is 9 yards. So at this moment of time, r is equal to 9. So that's going to go right here for r. So we have pi times 2 times 9, because r is 9, multiplied by dr dt, which is 7. So 2 times 9 is 18. And if we want to leave this in terms of pi, just leave pi in your answer. So this would be 18 times 7, which is 126. So dA dt is 126 pi yards squared per minute. And if we want to estimate 126 times 3.14, that's 395.64 square yards per minute.